Hello guys, so here is another question based on network theory from GATE EC 2021. So in the circuit shown in the figure, the switch is closed at time t equal to 0 while the capacitor is initially charged to minus 5 volt. That is Vc of 0 is equal to minus 5 volt. So here is the circuit and it has a voltage source of 5 volt, 250 ohm resistor and a voltage control current source and then another 250 ohm resistor, and at t equal to 0 this switch is closed and we have a 0.6 microfarad capacitor which has an initial charge of minus 5 volts. The time after which the voltage across the capacitor becomes 0 is dash milliseconds, and we need to round it off to 3 decimal places. So how to approach this question is, so if you see this circuit, it is nothing but a RC network and it is having a single C. So it will boil down to us having a single pole system, right? And your single pole system will have a single time constant. So here to find the time constant, your C is already given, but you need to simplify this part of the circuit to find your R. And your initial value of the Vc is given, which is minus 5 volt. And if you know the final value, you can just relate them through the exponential settling and you can find where your capacitor voltage becomes 0. So as a first step, let us try to simplify this part of the circuit. So what do you see here? So here it is given that if this voltage is VR, there is a current of VR by 500, right? And one way to simplify this network is nothing but finding your V Thevenin and R Thevenin and converting into a form like this, right? So VTH and RTH, and then you have a switch which is closed, and then you have this capacitor. So this is the easy way. And to find this, what you have to do here, since there is a voltage control current source, you can put a voltage source here of 1 volt and find the current I, and your RTH will be nothing but 1 by I, or you can also put a current source of 1 ampere and find the voltage V, and then your RTH will just be V. This is to find your RTH, and to find VTH, what you have to do, you can just simply solve this circuit to find the voltage here. Okay, so this is how you will solve if you go by the usual method, but there is also something similar if you are intuitive enough to find it. So let us see that. So here what you have, here you have VR as this. So VR is this, what will be the current flowing here? It will be VR by 250, right? And there is VR by 500 flowing downwards. So what will be the remaining current here? It will be VR by 250 minus VR by 500, which is nothing but VR by 250 into 1 minus 1 by 2, which is nothing but VR by 250 into 1 by 2, which is VR by 500. So if only 250 ohms were there, what was the current? VR by 250. But now effectively at the output of this thing, we are getting VR by 500. So it is same as writing this like this. So there is 5 volt and there is VR here, let's say. And instead of 250, I'm going to put it as 500. And then I have a 250 ohm here. So now effectively is the same current flowing here. As my VR changed, here VR is 5 minus whatever was the voltage here. Let me call it V1. Here also the VR is 5 minus V1. So nothing has changed. So it is like effectively your 250 ohm resistance has become 500 ohm. Now if you see, it is very simple to find VOC and VTH from this side, right? So you just have to find the look-in impedance and your open circuit voltage from this side. So what will be your VOC? Your VOC will be 5 volt into 250 by 500 plus 250, which is nothing but 5 by 3. Similarly, what will be your RTH? For RTH, what you have to do? You have to short your voltage source. So then your 500 and 250 ohm comes in parallel. So 500 into 250 by 500 plus 250. So this is nothing but 500 by 3 ohms. Okay, so now what circuit do you have? You have VTH, which is 5 by 3 volt, and then 500 by 3 ohm, and then a cap of 0.6 microfarad, right? 0.6 microfarad with an initial charge of minus 5 volt. So what is the time constant of the circuit? It is equal to RC, which is nothing but 500 by 3 into 0.6 micro. So this is 0.2. So this will be 100 micro or 0.1 millisecond. So now the time constant we have got, and it is a single RC circuit, right? Simple RC circuit. So how will the response look like for this? So this is like a step response, right? So for Vc of t, at t equal to 0, it was minus 5 volt. And at t equal to infinity, what will be its voltage? It will be whatever is the voltage this circuit is providing, right? So it will be 5 by 3 volts. So somewhere here, 5 by 3 volt. And how will the response look like? So from here to here, it will have an exponential thing. And it will finally settle at t equal to infinity. So how do I write this in equation form? So my Vc of t is equal to minus 5 and it is present at t equal to 0. So I'll put it as e power minus t by tau. If you see, when I put t equal to 0, this comes as minus 5, and at t equal to t tending to infinity, it vanishes. So at t tending to infinity, what should be the value? It should be plus 5 by 3. So plus 5 by 3 into 1 minus e power minus t by tau. So here this term, if you see, at t equal to 0, it is 0. At t tending to infinity, it becomes 1. Similarly, this term, if you see, as I said, at t equal to 0, it is 1, and at t tending to infinity, it becomes 0. So this will be the response. And if we simplify it, we'll have 5 by 3 minus 5 minus 5 by 3 e power minus t by tau, which is minus 20 by 3 e power minus t by tau. And we want this voltage equal to 0 at some t, right? So we want to find that t. So if we take it to the other side, we will have 5 by 3 equal to 20 by 3 e power minus t by tau. And this goes away. This is 4 times. E power minus t by tau is equal to 1 by 4. So if you take ln on both sides, what you will have? You will have minus t by tau equal to ln of 1 by 4. Ln 1 by 4 is nothing but minus ln 4. And minus minus you can cancel. So t is equal to tau ln 4. And your tau itself was 0.1 milliseconds. So your t is equal to 0.1 ln 4 milliseconds. So this you can calculate using your calculator. And it comes out to be 0.1386 millions. And they have asked us to round it off to 3 decimal places. So we should write 0.12139 milliseconds. Okay. So this will be my answer.